Welcome, beloved learners. My name once again is Mr. Paul Chilola. Welcome to the platform where you learn the sciences, including mathematics, all for free, in solidarity with the Malawi government to offer free secondary education. So on this platform, you have access to free science education. All you have to do is subscribe to the channel so that you do not miss on any videos that I upload in future, entirely for free. So welcome, inform your friends, wherever they are, that it is possible to learn the sciences, including mathematics, for free on this platform. So welcome to our Form 3 topic. This is the first topic of your Form 3 chemistry. All right. Your first topic, Form 3 chemistry topic, is called chemical weights. Chemical weights. So in lesson 1, we defined a chemical waste as a product or unwanted material from a chemical reaction, or an expired product which is no longer needed for any experiment in the next activity. Let's suppose that you are carrying out a chemical reaction in which you are reacting a metal such as sodium with water, right, to form a product such as sodium hydroxide and the hydrogen gas. All right, so in this case, the product is sodium hydroxide, NaOH. So you may not have any use for sodium hydroxide solution which you have made. All right, so this therefore is considered to be a chemical waste. All right, because it may not be required again in a future activity. Therefore, it is considered to be a chemical waste since it's a product from a chemical reaction. Another example could be, let's suppose that you burn paper. You were burning paper. When you burn paper, you form a product such as ash. All right, so the paper will burn completely into ash. Therefore, this is considered to be a waste. All right, it's considered to be a waste. Okay, so more examples of wastes generated in the laboratory as you conduct different experiments are unused chemicals such as acids, alkalis, solid chemicals. For example, let's say you are carrying out an experiment in which you are dissolving sodium hydroxide pellets, right, which are placed maybe in a container such as a dish. All right, so maybe the instruction says add the pellets to water, and you find that after doing this, you make a solution of sodium hydroxide, but you still have some pellets remaining. So these remaining pellets, sodium hydroxide pellets, are considered to be wastes. So unreacted substances such as solid chemicals, acids such as hydrochloric acid, alkalis such as potassium hydroxide, sodium hydroxide, if they have not been used, they are considered to be wastes, must be treated as wastes. All right, broken laboratory glassware, sometimes accidentally, you can drop a glassware such as a test tube, all right, which shatters in two pieces. All right, these, if not properly handled, can cause injury. So they are considered to be wastes. Let's suppose you dropped a thermometer which is made of glass, all right? So if it's not properly handled, it becomes a chemical waste. Plastics, waste papers used to wipe the benches as you work are considered to be waste. Poisonous gases, some chemical reactions will produce gases that are poisonous. For example, carbon monoxide is considered to be poisonous. Gases such as nitrogen dioxide, all these are poisonous gases. All right, so we've looked at the definition of waste, and we have also seen the examples, some examples of chemical waste, in case they ask you in an exam to list down any 3 or 4 examples of chemical waste. So you should not go wrong. These are the examples that we just gave. All right, so what are the different ways of disposing chemical waste? All right, for each type of waste generated, there must be a proper way to get rid of it. All right, so these are called safe ways of disposing chemical waste. All right, one of the ways of disposing chemical waste is the use of normal waste bins. So we have strategically positioned waste bins. Let's say this is your lab. This is your lab. Okay, so strategically you place a bin just at the corner there where waste can be thrown into. So every time you generate waste, this can be swept and thrown into this bin. This is a normal waste bin. It's called normal waste bin, into which wastes are thrown. Okay, as they are generated in the lab, you sweep them, collect them, gather them, and then throw them into such a bin. So this way can be used for waste such as non-recycled plastics, plastics that cannot be recycled, pieces of food, rubber, and dirty papers. All these can be swept, collected, and dumped into the normal waste bins. All right. Another way to dispose waste safely is to use special controlled waste containers. All right, so sometimes you may have a specially designed waste container, all right, which in most cases has a lid. So this is a container, all right, which has a lid. Okay, so these are called special controlled waste bins or waste containers. These can be used to dispose of sharp objects such as scalpels, needles, and anything that is sharp. Even broken glassware can also be thrown into it. All right. Sample tubes. Let's say you used some tubes to collect sample, biological sample or specimen. They can be dumped into this. All right. Items that are contaminated with hazardous chemicals can also be dumped into this type of container. These must be emptied regularly and not allowed to overflow. So do not let these fill up the container. It should be, each time you feel you have collected the waste, maybe 3/4 full, this should be taken to a place where it can be emptied. All right, so these must be emptied regularly. Do not allow this to fill up so that it can overflow. All right, so we are saying these must be emptied regularly and not allowed to overflow. All right, so they can ask in an exam, name any 2 examples of waste that are disposed using special controlled waste containers. So you can mention any of these sharp objects such as scalpels, broken glassware, sample tubes, items that are contaminated with hazardous chemicals. All right, so we are still looking at more ways to dispose of waste in a safe manner. So far, so good. I hope you're following. In case you have questions, don't hesitate to leave a comment in the comment section below, or better still, you can text me your question on the number that I provided earlier on. All right, there are some wastes which you simply have to drain into the drainage system using the sinks, the sinks that are strategically placed in your laboratory. So you can simply throw your waste into the sink and allow the waste to drain. All right, so we call this draining using a lot of water. So you drain your waste into a sink and let as much water as possible run into it so that all the waste can be drained into the drainage system outside your laboratory. Waste which can be drained include harmless soluble organic salts, all right, contaminated and used acids and alkalis can be disposed of using this method. Detergents such as soaps can also be disposed of using this technique. All right, I hope so far so good. If you are new to the channel, once again, consider subscribing to the channel so that every time I upload a new video, you are the first one to know, to tell that a new video has been uploaded. All right, moving forward, another technique is called recycling. Recyclable materials include broken glass, packaging waste, and paper. These can be recycled into something useful. Remember, recycling is a process of converting a material into something else that can be used again. All right, so broken glass can be heated and reshaped into something that can be used again. Packaging materials can be redesigned into something else, and it can also be used later. So this is called a recycling method. It's a technique of reducing, disposing of waste or managing waste. All right, another one is incineration. Incineration simply means burning. So this is a technique which involves burning waste. All right, so the wastes are burned and converted into something else. All right, turning them into ash, for example. All right, so this is called incineration, where wastes are burnt to convert them into ash. Then this is a technique called incineration. All right, okay, so in this incineration process, the wastes are put into an incinerator. This is a chamber where the wastes are burnt. The waste can be incinerated. The waste that can be incinerated including syringes, needles, organic solvents, soluble organic solvents, paraffin, mineral oil, and others. This is mostly used in hospitals. If you have visited major hospitals, you find that at their backyard they have this facility where they burn waste. All right, so the facility used like that is known as an incinerator, and the process of managing waste by burning them is called incineration. All right, so that was about waste and how waste can be managed. Waste can be managed like in those ways, 4 ways. Make sure you know all the ways of safely managing waste, and also for each technique, make sure you know the examples of waste that can be managed like that. All right, so welcome to a subtopic of the topic experimental techniques, which is called designing a scientific investigation. All right, it would help, for the sake of this lesson and the syllabus, to define a scientific investigation. We define a scientific investigation as the systematic process of trying to find an answer to a problem. All right. It's a systematic process of finding an answer, trying to find an answer to a solution, or a solution to a problem or observation. All right. Since we are saying that the process is systematic, it means that there are steps to be followed. All right. Because there are steps to be followed, therefore the process is considered to be a systematic process. It's a systematic process. All right. I hope so far so good. And in case you have just joined us, my name once again is Mr. Paul Chilola, wishing you a beautiful learning experience. Remember that learning on this platform is entirely for free. We are in solidarity with the current government, which is going to offer education for free to Malawian secondary students, and in trying to be in solidarity with that, this platform offers science education entirely for free, meaning at no cost. But if you need extra tuition, we are available to help you at a small fee. But for the time being, by just subscribing to the channel, you will have the privilege to learn all the sciences for free. So, the first step of scientific investigation is to identify a problem. You cannot solve a problem without a problem itself, all right? So first and foremost, we need to identify a problem. Identifying a problem involves asking questions about the natural world. Examples of scientific problems or questions include what causes rusting. All right, you have seen metals changing color. Okay, so you ask yourself what is causing it. All right, that's a problem. So you carry out a scientific investigation to find the answers to the question, what causes rusting? Why do plastics not decompose easily? Why don't plastics decompose easily? That's another one. All right, so first and foremost, identify the problem. Then, having identified the problem, you formulate what is called a hypothesis. All right. A hypothesis is basically a guessed answer to a problem. A hypothesis is formulated from the scientist's experience and the knowledge. So using your everyday knowledge and your experiences, you form a guess. You guess what causes rusting. You guess why plastics do not decompose. So we are saying in order, okay, problem identification is the first stage, followed by formulation of a hypothesis. Once you identify the problem and you have formed a logical guess, which is the hypothesis, then you carry out the actual experiment. So, an experiment is basically a series of investigations intended to either accept, modify, or reject the hypothesis. Firstly, you observe and collect data, which is the fourth stage. The fourth stage of scientific investigation is to observe and to collect data. So this stage involves writing observations correctly, stating the correct units of your data. All right, if there are any measurements, you have to state the units of the measurements. All right, and scientific data is best collected using tables. And then the next stage, which is stage number 5, is to interpret data. So you make sense out of the data. You attach meaning to the data that you collect. So interpreting data simply means explaining the observations the trends, if there are any, in relation to the aim of the experiment. Then lastly, you make a conclusion. All right, you make a conclusion based on your observations. All right, the conclusion is supposed to be drawn based on the collected data. It is either a formation, a confirmation, or the rejection of the hypothesis under investigation. If the hypothesis is correct, it is confirmed and expected, adopted, and if it is false, it is declared null and void, hence rejected. When the hypothesis is rejected, another one is formulated and tested. This is just a quick one to take you through the stages of a scientific investigation. Make sure you know all these stages in order of occurrence. In case they ask you to describe the stages of a scientific investigation, so just go through the stages again, and then you should be able to order them in a logical manner. Welcome to a subtopic of the topic scientific investigation, which is the first topic of Form 3 chemistry, purity of a substance. All right, how can you determine if a substance is pure or is not pure? All right, so it would help us to define purity of a substance. A pure substance is a material that has constant composition and consistent properties throughout the sample. In other words, a pure substance does not contain impurities or any other contaminants. All right, an example of a pure substance is water. If water contains only H2O molecules, then that means such water is pure. So for water to be pure, it means it contains nothing other than the water molecules themselves. All right, if we add salt to water, then the salt in that case is impurities. Therefore, the water is not going to be pure. All right, another pure substance is ethanol. If we have ethanol, C2H5OH only in a container without anything else in it, then we have pure ethanol. So pure ethanol is one which does not contain anything in it except the ethanol molecules themselves. All right, that's what it means by a pure substance. When we meet again, we are going to look at how the different ways of telling if a substance is pure or is not pure. All right, so that's a technique known as purity criteria for purity. Criteria for purity is just a group of experiments that can be done to determine if a substance is pure or is not pure. All right, in this case, we use what is called boiling point. You can use melting point. You can use chromatography to tell if a substance is pure or not. You can also use density determination, among others. All right, so this is going to be a lesson for next time. My name once again is Mr. Paul Chilola, wishing you all the best as we meet again in the next lesson. Please, if you have not subscribed to the channel, kindly consider subscribing and hitting the notification bell so that every time we upload a new video lesson, you are the first one to know. For now, let's meet in the next lesson. Bye-bye.